Hey everybody, my name is Owen Schacherer. Like Brian mentioned, I work for Schacherer. I'm a software consultant. I'm currently working in the financial technology space for a client out here. Right now, the main technology that I work with is Java. However, I have a few years of experience with .NET. And Brian didn't mention this. Oh, sorry, not Brian. Mark, right? Matt. Oh, I'm sorry, Matt.
You got
it. He didn't mention this, but I was here last year as well. I presented about Azure DevOps. Covered some interesting things there. I'm hoping this presentation can be as interesting as that one was. It can be, a little technical and whatnot, but I hope to point out some things for you guys that help you understand as just a, whether you're an architect or a developer, or wherever you fit in the tech space, what you can do to improve your documentation using UML. Whether you're empowered on a team to make those sort of changes or not, I guess that depends. But let me know if you guys have any questions or comments during my presentation, and I'd be happy to have some sort of conversation or answer your questions if I can. I would like to say that I'm not a pro with this sort of stuff. I learned about it in college. I made a lot of diagrams back then, and in my professional work, as you guys know, a lot of tech companies don't really worry about documentation too much, so I haven't really dealt with it in my professional work. But anyways, we'll get right into it. I'll introduce you to the Unified Modeling Language. The Unified Modeling Language was originally developed in 1997 by Grady Booch and Jim Brumbaugh and Ivar Jakobsen. It was adopted by the Object Management Group, also known as OMG, after it was created, and when it was first adopted at version 1.1, it was first adopted as version 1.1, and then it's been carried by the OMG group to 2.5.1, and it's undergone many changes and done a lot of growing since then. In 2005, UML was standardized by ISO and IEC, that's the International Organization for Standardization, and the International Electrotechnical Commission. And if you're interested in the exact standard, it's 19501. I'd like to know, because I've heard from many of you, but have any of you heard of UML before? Would you mind raising your hand if you've worked with it or heard of it, if you're familiar with it? Okay, definitely a large part of the group, that's good. Do any of your organizations or the teams that you work for, would you mind raising your hand if they use UML? No, that's not surprising. Well, what is the Unified Modeling Language? UML is a language for expressing and visualizing systems, especially their structure and behavior. These systems include business processes, software systems, and others that can be objectified. UML uses standardized symbols and terms for the creation of their diagrams. In this presentation, I've tried to keep it very general because I like the idea of potentially applying these things to things outside of software. I like the idea of, maybe you're working on something complicated at home and maybe some sort of visualization might be useful there. Sometimes it can be difficult to put some sort of visual or some diagram together for yourself that really gets the point across that you're going for, even in your personal projects. So using this will be a great help in really any domain. What is a UML diagram? A UML diagram is a visualization of the structure or behavior of a system using the Unified Modeling Language. As you can see right there are really two families of UML diagrams, the structural diagrams and behavioral diagrams. There's a lot of intricacies that go into all these diagrams. I won't cover all of it today because they're honestly really complicated, and that would be a very, very long presentation. They're useful for communication, visualization, documentation, analysis and design, and standardization. UML diagrams can be made for many things, most of which can be summed up by architecture, components, interactions, and processes. Sometimes systems or processes can seem intangible or overly complex, especially, I've had clients where it just seems like I've got to ask a million different questions to a million different people in order to know exactly what's going on. Especially as a software engineer who's oriented towards unlocking efficiencies, UML diagrams are a valuable tool for communicating to new team members or stakeholders, stakeholders who aren't really familiar with a bunch of technical jargon, Additionally, through standardization, exact processes for documentation and design can be put into place without all the overhead of designing that system you want everyone to be familiar with. These diagrams are useful for analysis, design, and implementation for our architects, engineers, and developers. The first family, the structure diagrams family. They are a family of UML diagrams that model the static structure of a system. These are used in detail for documenting system architecture. The 7 structural diagrams described in UML2 include class component, object, composite structure, deployment, package, and profile. And they appear there on that slide. The very first one. This is, I would say, the most common one. However, maybe use case diagrams would be a little more common, but there are really two main aspects to a class diagram. There's class notation and the class diagram relationships. They all come together to make a class diagram. Class diagrams are fundamental to object-oriented design. They model the structure of a system by documenting its classes and their attributes, operations, relationships, and multiplicities. Classes are notated with a name, their attributes and operations, and these in turn, as you can see by this little marker here, and the plus sign, they can also be minus signs, they mark their visibility, reflected in code, like, oh, public class, private class, Classes come together in the class diagram with relationships and multiplicities. There are many different relationships they can have. It might be a little hard to see back there. Something like realization, you would connect a class to an interface, and basically it would sign a contract saying that this interface, or this subclass is going to uphold all of the different operations described in that interface. Generalization, that's a way that you can create an extension for a class, just like you see there with the animal parent class, duck, fish, and zebra as subclasses. They, as you know, you can't make, animals don't exist in the fact that there's not like a species called an animal, right? They're a family. And that generalization can allow you to extend that and carry on the different properties and operations that the animal parent class has, and then pass it down to the desired child classes. Now we're going to do a little exercise. I hope everyone looks okay. Yeah, that looks better. I have 4 classes here. One of them being shape, another being rectangle, a third being square, and a final one being circle. I want to take you guys through what it might be like making a class diagram from actual C# code, as you guys are all familiar with .NET. First, we'll look at the shape abstract class. The shape abstract class is marked as public. It also contains 2 different operations, or 2 different methods, I suppose, and those being public each and both returning doubles. They're abstract methods, so they don't actually have any implementation there. So this reminds me to the scenario that I mentioned before about an interface. So right there you can see the contract that gets created for a shape and any shape that would implement this abstract class as well. They have the two operations in the contract marked with a plus sign, so they are seen as public, no parameters, and they return doubles. In all cases, when there is some sort of type declaration in UML, they have the semicolons to imply it. Next, we'll take a look at the circle. The circle class, it extends shape. Therefore, it must implement the two operations that were contracted by the abstract class, and it also contains some private class variables in order to calculate those required things. The final thing that Circle has is a constructor, and even in UML, constructors are represented in the operations. I didn't mention this previously, but these two different sections, the top one is specifically for the attributes. They're referred to as attributes in UML, however, in a class, the class variables. That top section is for the class variables, and then the bottom one is just for operations. So we have the circle there, and it's attached to shape using the arrow that I mentioned previously, which is the realization arrow. This is because it is not inheriting the implementation of the shape. It is being held responsible for the contract that shape has defined. We move on to the rectangle. The rectangle class is a shape just like the circle. However, it needs to calculate its area and perimeter differently. If you've taken geometry, you know that. It similarly has all the methods that the circle had, and it has two different what do we call them? Class variables. So in our diagram, we create an association the same with the realization line, and instead of radius, we have the length and width variables defined, and we have the operation for the constructor. Finally, the square. Square is a special case of a rectangle where all the sides are equal, and in this case, square is extending rectangle because it is a rectangle. However, the way that it calculates its area and perimeter are the exact same, so we don't need to override the previously defined rectangle methods. What we need to do is just pass into the rectangle base constructor the side for the length and the width. And instead of using the realization association to connect rectangle and square, we're going to use the generalization association because it is not getting assigned new contract, and it is just of the same type and going to use all the existing functionality in it. Does anyone have any questions over those things that I went over? Or for this specific example?
Just kind of a little bit trying to understand from this picture, how can I see is this the indication of the plus sign is that the actual calculation is defined on this specific object. So let's say area is defined as under shape, or and then everyone's inheriting that specific calculation, or.
So are you asking, when it comes to the rectangle, how the square is inheriting those operations?
Yeah, I'm looking at basically trying to see some things. So that one, the shape is defined as interface. However, we have it defined as abstract class. did the area have the, it was a pure abstract class, right?
The shape is.
Yeah, shape was a pure abstract class, so theoretically it could be interfaces. Okay.
And actually, to kind of comment on your question, now that I see it here, thanks for bringing it up, this is supposed to be a hollow arrow in order to mark the generalization. And basically, that specifically the definition of the generalization association is inheritance. It says whatever this class has, and more because of whatever it finds. The UML component diagram. Looks like there's a lot going on with this thing. It's a pretty complicated system, and there are many different components involved, many different parts going on, but the component diagrams lay out system components and their relationships, building its organization and dependencies. Component diagrams are largely made up of components, interfaces, and ports, all of which are pictured here. Components are modular parts of a system that can be replaced by other logically equivalent or conformant components. So even here we have staff marked as a component. That, as someone in software, that seems a little, random. Why aren't these services? Why aren't these classes? Why aren't these things we're familiar with? Well, because staff is very general, and it's really just a component that meets a specific function for another component within the system, and it can be swapped out, and as long as it's something that's conforms to the same ability and responsibility that a staff member would have. There are two different types of interfaces. There's provided interfaces and required interfaces. One provided on the left, required on the right. Provided interfaces are symbols with a complete circle at their end, representing an interface that the component provides. Required interfaces are half-circle symbols that indicate what a component depends on. This system specifically is offering up state, details, inspection items, and it requires account and inspection ID. Maybe if you were to create a component diagram for an API, you might have interfaces representing the exact port that the application gets interacted with from outside. Granted, now we'll move on to ports, which, like the example I just mentioned, might be a little confusing. Ports aren't necessarily referring to exact network computer interactions. They are parts where interfaces connect to that are points which they're interaction points, which components and other classifiers can communicate with its environment. This is a very, very simple UML composite structure diagram of a car. I think that is referred to as a containing classifier. The car is a containing classifier for all of those internal components there. Obviously, if you drive a car, you know that that's not all the components they have. But whether working with classes, components, or systems, composite structure diagrams can be used to show their internal structure. So similarly to those components that were referred to in the previous diagram, this might better or more in detail define the internal components. This structure arises thanks to the help of classifiers, parts, ports, connectors, and collaborations. This one's so simple it doesn't include all of those examples, but in this figure it does show the composite structure diagram that identifies the containing classifier car. The diagram frame shows 4 internal component parts, which represent the 4 wheels of the car and are of type wheel, similarly to the class diagram where the name and the type are separated with colons there. A communication link connects the front wheels and the rear wheels with connectors named front axle and rear axle. This is where it gets a little bit more complicated. This one's a lot more noisy. The deployment diagram shows which softwares are mapped to which hardware in a deployment. This can be accomplished with nodes, artifacts, dependencies, associations, specifications, and communication paths. Now, not all of those are pictured here. However, this is what a really good deployment diagram looks like. The nodes, which are the boxes, or sorry, they're all boxes, the cube or rectangular prism looking boxes, those are referred to as nodes, whereas artifacts are, they have a little file sign in the top right, and they are just rectangles. Nodes are either hardware or software, or some software execution environment. So really, they're more of a home for something. An artifact is a piece of information that is used either to produce, that's either produced by some software deployment or that the software development process, or sorry, the software deployment process uses. And here, intuitively, when you make a database, you know that really until you do some sort of process on the database after it's made, the schemas don't exist. So the artifacts here are marked properly as a result of a deployment process. I like the idea of these the deployment diagrams. My client does a lot of things in-house, and there's been a lot of at least confusion from my part because of the lack of documentation. And in order to know where, we have all these different servers with all these different applications running on them, exactly where things are, and if in the traditional, or I guess not traditional, but in maybe a more agile environment, these sort of documents can be updated regularly with any push to production or any push of code. So these things can stay alive, and all it would take is one minute for me to figure out exactly what I'm looking for and not have to look around or ask a bunch of questions. Communication paths are what you might expect by their name, an association between deployment targets through which they exchange signals and messages. This database server and this application server are connecting directly through the TCP or IP connection. This one is a bit more niche. This is a step above just the application of UML. This diagram allows you to extend the existing UML meta model or other meta models or other models. These diagrams use extension mechanisms to give the writer the ability to create domain and platform specific constructs. So if maybe an architect wants to create some sort of contract for a specific type of model in a database, this can be a way to document those things in one place or create other tools that are useful for diagramming. The given extension mechanisms include stereotypes, tags, and constraints. Stereotypes allow for the definition of new models from existing ones. This user stereotype is actually extending the class, the class model. It basically says that, like all inheritance, that it is a class, but with a few more intricacies. This specific property, or this specific stereotype defines the property login name of type text, which I will talk a little bit more about in the future. Tags, which are not pictured here, are name value pairs that are used to extend the properties of UML so that specific information can be added to a model element. Examples that might, I don't know exactly what I would put on one of these documents, but I do know of some examples, like if you were to be creating a stereotype for a specific hardware, that you might include in curly brackets underneath the name. Something like memory for 4 gigabytes, manufacturer, Asus. You might include also version numbers if you want to have some sort of version control. Constraints. This is the final aspect of the UML profile diagram. These ones are interesting to me because I have a lot of conversations with architects because of the lack of documentation about specific things stored in our database or specific parameters that come through our APIs. Using constraints, you can imply semantics or conditions that must always be held true for a given property. An example would be the login name shown under the user stereotype, where you might require that the login name always be alphanumeric and less than 20 characters. And if it's stored here on a diagram, no questions really need to be asked to who knows what about what, and you just refer to one place. In this example specifically, it is defining a profile that is being applied to a larger IT management group, and it also shows several different profiles that are defined there. Now we'll move on to the next thing. Behavior diagrams model the dynamic internal processes of a system, including interactions with other systems. These just so happen to be my favorite ones. There are many types of behavior diagrams, one of which has children. The set of behavior diagrams include activity, state machine, use case, and interaction. Interaction diagrams having the children communication, interaction overview, sequence, and timing. Activity diagrams are a lot like, what are they called, control flow diagrams. They're a little different, however they serve fundamentally the same purpose. Activity diagrams are used to illustrate workflows and processes. They have 5 main components: activities, transitions, decisions, start end nodes, and swim lanes. This example specifically doesn't show swim lanes, but where you might use swim lanes would be a process that interacts with multiple different actors. Like if you wanted to model the interaction at like a sales counter, where one part is where the customer goes, picks up the groceries, comes up to the counter. Another part would be in a separate swim lane where the employee brings up the groceries, and if maybe there's an issue, they call over their supervisor, where the supervisor performs their part in the process. This example here shows all of the different components that I mentioned, including a few others. At the top, we have a start node moving to an activity of receiving an order. Yeah, this describes the order to fulfilling an order process. The black box there shows a fork in the process, which is actually a part of UML where you can show concurrent processes. I thought that was interesting. I had never heard of a fork before, or the, like I'll get to later on, the join there. So at the same time, on the left and the right, we have 2 different processes going on once an order is received. On the left, we have the fulfilling of an order, where first we'll fill the order, we'll make the boxes up and get everything ready to ship. Then we'll decide where the diamond there shows whether or not a rush is required for this order. And if it is required, then we'll arrange for overnight delivery. If not, then we'll arrange for regular delivery. After that, so after those activities take place, we'll join again with that bottom triangle. And on the right side, as all that's happening, we'll send an invoice, receive payment, and then finally join back together in order to end the process. We'll take a look at one more example of these that I made up. It's very simple compared to the last one. However, this one has a code example for it. This is the calculation of factorial, as the method says there. There's basically a one-to-one basically a one-to-one relationship between each line of code and an activity. After starting, we'll instantiate n, which is a parameter given in our method. Then we'll move on to creating the integer result, setting it to 1. Once we get to the for loop, the first thing that happens is the integer I is created and set to 1. Then a decision is made whether I is less than or equal to n. That's represented here in the triangle. I put some text over the association line in order to know exactly which direction is which. If we are free to move on with the for loop, then we will multiply results and set it equal to the result times I. After that executes, we'll move on to incrementing I and reviewing again whether or not I is less than or equal to n, and continue that as long as it's true. And once it's not true, then we'll move on to outputting the result. We can see that if, let's say, you want to calculate the factorial of 2, then 2 would go down, in result would get set to 1, I would get set to 1, 2 would get compared there where I is less than or equal to 2. We know that 1 is less than or equal to 2, in which case we can multiply it by I, and that would be equal to 1 in that case. 1 times 1 is 1. Then we'll increment I, making it 2, where they're equal. Then we're free to move down below the triangle again and multiply 1 by 2, which is 2, set equal to the result, and increment again. At this case, in this instance, I is 3, which is not less than or equal to n, and we'll move on and output the result, ending with the end node. UML use case diagrams. They describe the interactions between actors and systems. These diagrams are put together with actors, use cases, associations, and system boundaries. The association lines pictured here, they basically represent that the actor connected to them is associated to the use case in whatever it's connected to. So these circles, or not circles, these ovals here, they are the use cases. And in handling a message for that you would send from your cell phone, one part is the cell phone, there pictured on the left, where it actually has to initiate the sending process, and it's received by the external phone company in order to handle that message. Same with handling a call. And when it comes to managing a bill, there's an argument that maybe the external phone company has something to say about that bill, but I think this diagram here is really describing a system that's creating that bill. So in order to manage it, it's really only up to the customer at that point. A sequence diagram illustrates interactions between objects in a system over time. This diagram is showing the interaction between a user and a seat reservation system, just like if you were to go to a kiosk at a movie theater. In order to start the process, the actor inserts their card into the kiosk. They will select a date for when they want to watch their movie. Then they will be offered up a seat from the kiosk after those two steps. Once the user selects a seat that they would like on that given date, it will be fed back to the kiosk, which then passes it on to a server to submit the order. The server will handle that order, whatever is necessary, save it to a database, change around different saved data in a database, and then it will send the confirmation from the server back to the kiosk, and then finally return it to the actor. All right, how can UML diagrams be created more easily? know, you could obviously write them with paper and pencil, but luckily we have a lot of software today that can help us. There are GUI-based tools which enable users to create UML diagrams using drag and drop, similarly to the way that Microsoft Paint used to work. I'm sure a lot of people here are familiar with diagrams.net or Lucidchart. Also, I discovered this when doing some research. Lucidchart isn't necessarily just a software that you can use to make diagrams. They also have a lucid.app on the web, which is their own little platform for housing those things. These are all free examples: diagrams.net, lucid.net, and Visual Studio Class Designer. I thought you guys would be interested in Visual Studio Class Designer. Oh, actually, that's a copy and paste error on my mistake. That is actually supposed to say Visual Paradigm Online. So Visual Studio Class Designer is actually a code-based diagram building tool. If you download it onto Visual Studio, you will be able to automatically create or update your, you'll be able to automatically create or update different class diagrams specifically. So those are only for class diagrams, but it's something that .NET users can take control of in Visual Studio. Other code-based diagram building tools are Plant UML and Mermaid JSON. From the research that I was doing, I really thought that Plant UML looked like the best tool. It was really capable of making all the different diagrams from UML, also other diagrams that they had defined. So code-based diagrams are building tools that give the developers the opportunity to add diagram changes along with their functionality changes in their pull requests. So to me, that seems like a really, really good way to add documentation creation into already existing processes that a lot of different teams already use in software development. With Plant UML, they have their own custom language in order to create many different UML diagrams. Additionally, they can be stored inside of Plant UML files, text files. Yeah, Mary?
The Visual Studio Class Designer, does that generate something off of an existing project, or is that something you built from scratch and then use alongside your project?
It will build it from an existing project. Yeah, and there is a lot of documentation about it. I was able to find Microsoft examples and several other websites that gave, they were all really short too. It seemed very simple, like just a few steps in building the classes about the class diagrams. Going back to what I was mentioning, these Plant UML diagram text files or code files can be stored on text files, Java source, C or C++, and many other different types of files. All right. In conclusion, applying UML is an interesting and engaging exercise. Anyone involved in an organization or working with systems or processes can benefit from them, especially software developers, engineers, and architects. By applying the information provided here today, you can increase the transparency of your teams and organizations, better communicate complexity with team members and stakeholders, and document in a more digestible and standardized way. Thanks everyone, I appreciate your time. It was really nice speaking with you guys. Do you guys have any questions or comments about the presentation? Yeah.
Since you kind of dug in pretty deep, I've had a client that wanted a UML class diagram, and you kind of mentioned Visual Studio, it's super easy, it's just a couple clicks and you get it all output. It kind of feels like, I guess, what is your opinion on class diagrams? If it's that easy, is it worth even keeping around because it just gets outdated after a certain point? And if anybody can do a couple clicks and generate one, is it, like, what's your stance on keeping it around, or is documentation at that point that's going to get out of date? Or?
Yeah, that's a good question. I would say that they are important in terms of design, at least. So maybe they're better suited for the creation of new applications, or maybe more from an architect standpoint. Yeah.
I will say, I know that we mentioned that the Microsoft thing coming up, and that is mostly going to be with AI. Most recently, I did use their new Azure AI Studio, and they even have a setting that as you're setting it up, it'll create an interactable UML diagram alongside with it as you're coding, and like you can click on it and it'll highlight like what code is involved on it and everything. So I think that it's progressing is a good answer to like with AI. I'm guessing Microsoft is going to talk about it coming up soon. So
Yeah, that's good to know. You said Azure AI Studio?
It's a setting you can choose.
Yeah, with all the research that I was doing, I've noticed that you don't have to really take a bunch of time to write it all out. I think that there's a lot of really useful tools around nowadays, or to do it for free especially. That's really important, why pay for it when you don't have to.
So kind of question, it's kind of related to this question, but so the thing is that from my experience, it's maybe a little bit more common as well. Like and sometimes you get handed over, like you ask how this system works or whatever. You're handed over some sort of diagram. Maybe it's in UML, maybe it's somebody wrote it in paint.net or whatever. And you're trying to figure out how it works. It's quite straightforward and all that. But then you're actually looking through the system, and it's outdated. The diagram is like 5 years old. It's been used as a guide, so the original implementation was already outdated, this diagram, and then it was after that the system was enhanced a bit, it's changed entirely. So maybe there is some sort of a way of integrating this auto generation tools into the pipeline.
Auto generation, I wasn't able to find anything specifically to do that. I think that ChatGPT would be able to do it if it knew the languages that I was describing when it came to like plant UML. Like if you could give it an example of plant UML, use plant UML to create a diagram that does this, that would be a way, but I haven't been able to see anything that was, CI/CD pipelining based in that case. Mainly just developer defined was the best thing that I could find. I do think that if you work in a agile environment where you're producing value regularly, that as a part of any sort of change that affects I guess you would need to know. So let's say a team has a bunch of different diagrams, then that could be a little more confusing as to know how to which ones to grab to update. But if let's say you're just making a class change, then maybe it would be very easy to update them alongside the functionality change if you were to use the code-based options. And that would really just be a team standard or a team practices change that doesn't change any of the overarching things. It really just changes kind of the bottom of the practices.
Yeah, on that topic, I just had a conversation with one of the guys that I work with. I can't remember what day it was or what topic it was, but anyway, he had like this graphic diagram that he wanted to convert into Mermaid and have it be rendered. And so he just gave it to ChatGPT, said, "Can you build a Mermaid diagram of this?" And it just output the code form. It was actually really impressive. So yeah, it's going to be there. And eventually, you'll be able to point it at probably a DLL from an application and just say, "Can you document this for me?" Right, without even having the source code. So, yeah, it's in the future for sure.
Yeah, and there are APIs to interact with ChatGPT, so you could make some sort of interface with it where it would have to be a custom solution, because unless obviously you found something, but you could make a custom solution, it sounds like that, if ChatGPT is already aware of the language.
I'm curious, I think UML kind of grew up in the time frame where object orientation was really, really big and kind of the new thing, and you can see it in the way that it works out. in your experience, have you seen anything that supports a more functional perspective, like a functional paradigm in software? I don't even know what that would look like, but I'm curious if there was like a UML equivalent for functional programming.
So functional programming as in like scripting, like writing scripts.
Well, like a F# or Haskell or
Oh, man.
you know, it's a completely different paradigm. Yeah, Clojure would be another one. You don't, it doesn't, you know, it's stateless in the sense, so there wouldn't be any attributes on a inside of a functional application. So it would be very different. Like inheritance doesn't necessarily apply, or it's accomplished in a different way.
So it's more of a one and done sort of execution.
Variables like immutable, it's like, so like lambda expressions in the lib queries or whatever, that would be a good example of functional code, because it's just a function. It's, you know, it doesn't take anything from higher, it doesn't have a state, it's everything is immutable kind of states.
I probably can't give a good answer on it just because I've never worked with it before, but I can imagine that an activity diagram would still hold its weight there.
Yeah, there's obviously a lot, like activity diagrams, sequence diagrams, a lot of the later stuff that you showed in your presentation, I think would still applicable to basically any software development paradigm, but the inheritance and interfaces and you know, all that is very object-oriented, which is good, right? Because we're all .NET developers, we're probably doing object-oriented programming, but you know, C# is a multi-paradigm language, so illustrating some of the capabilities might be difficult with purely UML.
Oh, like you mentioned about how this kind of came about towards maybe the beginning or the middle life of object-oriented design and programming. A lot of the resources that I was reading were pretty old, so some of the sort of stateless things that you're mentioning probably weren't thought of back then, so I wasn't able to find anything like that, but it is an interesting
Functional
idea.
paradigm is very old, it's like from the 60s.
Oh.
It's
There's a lot of
just,
functional
don't spend a
programming in, like,
band.
domain-driven design.
Mm-hmm.
They have like a lot of UML kind of graphs in like books I've read on domain-driven design that are using F#, so I bet it's out there.
Yeah.
I have a LinkedIn connection for you if you,
Okay.
he would know exactly the answer to your question.
Yeah, I'd be curious to learn about it. Yeah.
I'll let you know.
Great, all right, well, if you guys have any questions for me or you want to connect, my name is Owen Schacherer. On LinkedIn you can find me, and that's my email right there.
Thanks, Owen.